Hello everyone, my name is Rani. I am studying at Institute of Aeronautical Engineering, BTech second year CE section, CSE. So today I am going to give presentation on sort operation of heap sort. So let's see. So my topic contents are introduction, heap sort operations of heap sort with example, algorithm, analyze the complexity, applications of heap sort, conclusion. So let's see the introduction first. So heap sort is a comparison based sorting algorithm based on binary heap data structure. So heap is a type of data structure. It is binary heap is a type of heap data structure. So it is normally based on binary heap data structure. Heap sort is basically a based on a binary heap data structure. It is similar to selection sort. So as we I think in selection sort the minimum element will be fine and it will be kept as fixed. So it is same like selection sort. It is similar to the selection sort where we first find the minimum element and place the minimum element at the beginning. Repeat the same process for the remaining elements. Means heap sort is same like selection sort. So how it is same? Let's see. So let's see the heap sort. What is how it is done? Let's see. Heap sort process the elements by creating the min heap or max heap using the elements of given array. So heap sort heap sort process the elements by creating the min heap or max heap using the elements of given array. It will go with the min heap or the max heap. Min heap or max heap represents the ordering of array in which the root element represents the minimum or maximum element of the array. So let's see, let's take a minimum heap. If it is a minimum heap, then the minimum of the elements, the minimum of array of elements will be taken as a root. For example, let's take a let's take four numbers 2, 4, 6, 8. Here 2 is the minimum number, so it is kept as root. So in such a way we will order in such a way the minimum number of the array elements will be taken as root in minimum heap. And if we come to the max heap, then the maximum number in this case 2, 4, 8, 6, 2, 4, 8, 10, right? So here 10 is the maximum number, so it is taken as a heap, taken as a root. And heap sort is a popular and efficient sorting algorithm. The concept of heap sort is to eliminate the elements one by one from the heap part of the list and then insert them into the sorted part of the list. So here the heap sort contains the two parts. First, we should heapify it. We should make it like a heap data structure, and then after we should find the minimum and maximum heap, and finding the minimum element or maximum element, making it a fixed element in the array. The concept of heap sort is to eliminate the elements one by one from the heap part of the list and then insert them into the sorted part of the list. Heap sort is the in-place sorting algorithm. So here heap sort doesn't take any extra memory like merge sort. The first step includes, see here, the as I said before, there will be two steps for forming the heap sort. The first step includes the creation of heap by adjusting the elements of the array. As I said, we should adjust the elements, like we should make the elements as a heap data structure. Okay. The first step includes the creation of heap by adjusting the elements of the array. After the creation of heap, now remove the root element of the heap repeatedly by shifting it to the end of the array and then store the heap data structure with the remaining elements. So let's understand this process with the example. Okay, now let's see the working of heap sort in detail by using an example. To understand it more clearly, let's take an unsorted and try to sort it using heap sort. Okay, so here my elements are 81, 89, 9, 11, 14, 76, 54 and 22. First we have to construct a heap from the given array and convert it into max heap. So here 81, 89, 9, 11, 14, 76, 54, 22. These are the elements, right? so we should make it max heap. Max heap in the sense I said before it, max heap nothing is nothing but the maximum of numbers, the maximum of given elements is kept as root. So here 89 is maximum number, right, biggest number overall elements, so it is kept as root. And under that 81, 22, 14, 11, 76, 19, 54. See here, see in the first 81 as the elements given, we took in the same order like 81, 89, 9, 11, 14, 76, 54, 22, right. See here, first the maximum number is taken as root, that is 89, and then after here 89, 11, 14, in these three, which is the greatest element? Obviously 89 is greatest one. So okay, next here coming down 22, 11, here 22 is greatest of 11, so it will be swapped, like 11 will become below, then after 22, and here if we change it, like here left will be 22 subtree and right will be 14 and root will be 89. When we comparing with the root with the super parent, that is 81, here 89 is greatest, so again swapping with that, so there will root will become 89 and left subtree root will become 81. So again doing the same process with the right subtree. Right subtree we have root 9, left subtree is 76, and right element is 54. Here in these three elements 76 is greatest, so making it as root, and like this we will perform. And after converting the given heap into max heap, the array elements are by converting it into max heap, we get elements like 89, 81, 76, 22, 14, 9, 54, and last is 11. Next we have to delete the root element 89 from the max heap. To delete this node, we have to swap it with the last node, that is 11. After deleting the root element, we again have to verify it to convert into max heap. So here the greatest element is 89, we should delete that greatest element and swap it with the least element, that is 11, like this. The 89 element is deleted and 11 is shifted to the root. Again we should heapify it. Here in this all 81 is maximum element, and in the left subtree there are like 22, 14, after making it swap there will be 11. So in this 22 is greatest, so making 22 as root, same like same. Next right subtree is already in sorted order. After swapping the array elements 89 with 11 and converting the heap into max heap, the elements of array 89 is already fixed by using max heap, okay, making it fixed at the last element. In the next step again we have to delete the root element 81 from the max heap. To delete this node we have to swap it with the last node 54. After deleting the root element, we again have to verify it to convert into max heap, and so on. So here the root element is 81 and the least element is 54, right. We should delete 81 and make it fixed stable in the array of elements, and then taking 54 as root element, as like this. Here see example, 54 is root, deleting that element, okay. Next again heapifying it. In these all elements 76 is greatest, so making 76 as root, and in the left subtree 22 is greatest, so making it same as root, and in the right subtree 54 is less than 76, so swapping it. After that 54 will become the root and 9 is like child node. Now here fixing the 81 which we have deleted earlier, right, making it stable, and writing the same elements 76, 22, 54, 11, 14, 9, and again deleting the root node which is 76 and replacing with the base node, that is 9, and 76 will be fixed in the array of elements. And again heapifying this data, like here in this given subtree, in this subtree 54 is greatest, so making it root, and then after in left subtree of it 22 is greatest, so it is root. So 9 is 9 and 54 are swap, and here 54 is fixed, and here 54 is fixed and it is replaced with 14. So again heapifying it in such a way the elements are uh, in such a way the greatest element is found, and that element is deleted and swapping with the least element, least node of the element. Okay, so here 14, 22, 9, 11. So 22 is greatest, so making it root, and then after 14 as child, and same here deleting again deleting 22 and 11 making it and swapping with 22. So 22 is fixed and 22 is fixed. Okay, and here this subtree will come 11, 14, 9. Here in this 14 is greater, so making it root, and 11 9 as subtrees, and fixing the 14 element. 14 in this is in the array of elements, and here 9, 11. If we heapify it, it will come 11 is greatest, right? So 11, 9, and again fixing the 11th element, 11 element in the array, and again see here only one element is there, that is 9, and if we heapify it, it will only come 9 because no other element will be is there to compare it with. Okay, and here the same element will be taken in the array. In such a way the sorting array will come. See here after this process we get 9, 11, 14, 22, 54, 76, 81, 89, which is a sorted array. So algorithm, let's see algorithm for this. So this as I said, this process contains this process contains two steps, that is heapifying it, deleting the array, deleting the root node, and swapping with the this node of the element, right? So here first the main algorithm, heap sort array max heap array for I is equals to length array of 2. So swap with swap array, heap size array is equals to heap size of array and 1. Heap maxify heap, here we are calling that method max heapify. So first it will build the max heap. It is like taking like data heap like data structure, making it as heap like data structure, and under that we are calling max heapify. Here max heapify array, which is taking array and left element, L is equals to left of I, R is equals to right of I. If L heap size array and right L is greater than, then largest is equals to L, else largest is equals to I. If R heap size array and array of R is greater than array of largest, then largest is equals to R, assigning it, and if largest is not equals to I, swap. See if the root node is not largest, then swap with the array of largest element, then max heapify. Again calling the max heapify array of largest, checking the condition. So time complexity of this algorithm, build a heap algorithm will run in bing of n times. So making the heap structure up to the n nodes, right? If there are 10 elements, we should make the 10 elements as a heap like data structure, so it takes 10 time, bing of n time. There are n minus 1 calls to heapify. Each call requires bing of log n times, so it takes a log of n time. Heap sort algorithm combine build heap program and heapify, therefore it has running time of bing of n log n time. So total time complexity of this heap sort algorithm is bing of n log n. So applications of heap sorts are sorts an array in bing of n long n time using binary heap. This is using binary heap. Okay, like binary two elements, priority queue, because binary heap provides insert, delete, extract, max, decrease key operations in bing of log n time. Priority queue may be created quickly. By using binary heap, we can create priority queue quickly. Binary heap has two variants, binomial heap and Fibonacci heap. These variants also do well when it comes to India. Priority queues are particularly useful in graph algorithms such as Dijkstrata shortest path and Prim's minimum spanning tree. So Dijkstrata shortest path is finding the shortest element between any two nodes, and Prim's minimum spanning tree. Heaps can be used to solve wide range of problems. So these are mainly, this may be used in a priority queues to develop priority queue, and it takes n log n time complexity using binary heap, and it may be used in a Dijkstrata shortest path, and it's also a wide range of problems. I am going to conclude this presentation. With its time complexity of being of n log n, heap sort is optimal. Unlike merge sort, heap sort requires no extra space. As we seen before, it is in place sorting algorithm, means it doesn't take any extra space for sorting. On the other hand, heap sort is not stable. A sorting algorithm is stable if it leaves the order of equal elements unchanged. Okay, this is not as stable. So thank you.